Hey class. So last time we were thinking about population growth and how those rates might change. This time we're going to think about how growth in a population might affect another population, another organism. All right, here we go. So we're looking at activity 5, changes due to population growth. And we started out by thinking about just, have you had any seafood in the last week? And if you have, where'd that come from? Something that you or someone you know caught locally? Is it something you bought at the store? Something someone gave you? Where was the original source of that food? And then one of the things we've talked a lot about in this class is overfishing and the impacts that can have. And so we try to think of, is there a solution that we can get around catching wild fish that might help with some of those overfishing problems? And so what if we did fish farms? We looked at this a little bit when we thought about lethal seas in those oyster farms. So could we extend that to other seafood species, other fish? So if you haven't already, make sure you read through the introduction because it's going to help open up this concept. And one of the things we're going to talk about is aquaculture and what that might look like. Make sure you read the section on the different aquaculture systems as well. And so what is aquaculture? It's the growing of fish and other aquatic species for human consumption. Our challenge question, our purpose was, how can the environmental harm from salmon farming be minimized? So we're going to try to explore those environmental impacts and see how we can minimize that. So what we did is we ran a simulation. So we said we're going to simulate that we run a salmon farm using some open net pens. We said that our starting population was 1,500. The wild population, remember these pens are in sort of a body of water where the wild population lives as well, and so we have to consider that wild population size as well. So we said, what if the wild population started at 10,000 fish? We used this chart in a number cube, and whenever we would roll a number, we would come up with a situation. So maybe some of our farmed salmon escaped. So then what's the environmental impact? Well, now those farmed salmon can breed with the wild population and compete with resources. So you have a loss of your wild population because of the lack of resources and the reduced fitness because of interbreeding. And then in this case, we said there was no change on the farmed population. So you can continue to go through. There's different options. You could see disease at the salmon farm affects both populations. Antibiotics that we give to increase our farmed population can ultimately disrupt the wild population. The number of fish in the pens has an impact. Actually, that can help improve the wild population. And then, if we have waste that accumulates and leaks out, that can cause environmental problems, as well as just the pens themselves. They take up space, and so that can reduce our wild population. Ultimately, there's not sort of a scenario we found where we didn't have an impact, a negative impact on one of the populations with that decision or with that situation. If we start to try to think about what do the numbers mean, so we have these population numbers, what do those numbers mean? We started out at carrying capacity, so around that 10,000 mark, we were sort of at carrying capacity, the maximum we could have in that wild population anyways. And pretty quickly we see that it starts dropping off into some stable and then overfished and critically overfished ranges. We also can consider the profit margin for our farm. So actually I'm going to flip ahead and show you this graph, and then we'll go to a graph to show the profit section. So if you think about the wild population, you see that it's starts dropping off, and if we think about what does that mean for the population, that within 4 or 5 generations we're into an overfished territory, and in this simulation by generation 14 we were extinct. I'll show the graph for the profit. So if we think about our farmed population, we see our population numbers. The other piece to consider is the profit. So out to about 9 generations, we were making substantial profit off of it. Pretty quickly it drops into a moderate profit, and by generation 12 we're now down into negative profit. So we're not even though our population's still there, we're not even making money off of our farm. So we're having huge impact, And it's not sustainable in terms of the environment, not sustainable in terms of the fish, not sustainable in terms of the economics, because pretty quickly it stops being a profitable enterprise. So you could think about what kinds of events affected your system, how those affected both the wild and the farmed population. And then kind of going back to our question, one of the questions we thought about at the beginning, do you think that the results of fish farming are helpful, negative, or mixed? There's definitely a lot of trade-offs we have to consider as we would work with our farm, for both the farm itself and for the wild population. And then what are those benefits and trade-offs involved with aquaculture? And remember to read and think about the different kinds of systems. So there's raceways, there's inland ponds, there's open net pens. And then just ultimately, how can we reduce and minimize environmental impact? These were our key vocab. We added aquaculture, but we saw some of these density-dependent and independent factors in the population and growth rate as we move through. So hopefully that gives you an idea about some of the impacts of aquaculture, and maybe just in general how we can try to think about environmental impacts from our choices and sustainability. If you have questions, let me know. Otherwise, we'll see you back in class.